Here at Sprott, we believe that nuclear energy is one of the safest, most effective, and cleanest forms of baseload power generation on the planet, and a major solution to reducing carbon emissions while providing reliable electricity. However, not everyone is as convinced, and one of the main concerns we hear is, yeah, but what about nuclear waste? Well, if that's you, we're so glad you asked, because in this video, we're going to educate you about the following facts. The solution to nuclear waste already exists, and is far easier than you might imagine. The amount of nuclear waste resulting from energy generation is very small, especially compared to other energy sources. There has not been a single accident or fatality involving nuclear waste, and the radiation present in spent nuclear fuel declines to levels that are harmless to all forms of life. Let's dive in. Part 1. The solution to nuclear waste already exists and is far easier than you might imagine. Water, concrete, and steel. These are the simple elements that do the majority of the heavy lifting when it comes to the solution for safely dealing with nuclear waste, or what is better termed as spent nuclear fuel. The two main dangers presented by spent nuclear fuel are heat and radiation, both properties that are easily measured. Spent fuel rods are the end result of nuclear energy generation, and when they've completed their duties and are ready to retire from action, they are extremely hot and radioactive. To deal with this, they are removed and placed in steel-lined cooling ponds made of reinforced concrete near the nuclear reactor. The water and steel are very effective at dealing with heat and radiation, and the concrete also helps to block radioactivity, so submerging the fuel rods in the cooling pond renders them harmless. Human beings with no special form of protection can stand above the pond with no negative effects. And these cooling ponds haven't just been thrown together. The science behind engineering the ponds perfectly to render the spent nuclear fuel harmless has been perfected over decades, and like everything in a nuclear power plant, is subject to extraordinarily strict oversight that ensures no mistakes are made in their construction and utilization. Now, while these cooling ponds are sometimes designed to store all used fuel for the full life of the nuclear reactor it services, most of the time, after a year or more in the pond, enough time to greatly reduce the amount of radiation they emit and remove the heat, the spent fuel rods are transported to the next stage of storage. This involves placing the rods into dry storage casks that each weigh north of 150,000 pounds, sealed in an extremely thick shell of reinforced concrete and stainless steel. In fact, only a quarter of the cask volume is spent nuclear fuel. The remainder is all steel and concrete. Like I said, it's simple, but it works. Like with the cooling ponds near reactors, a human being, or any life form for that matter, can hang out beside these casks and even lean against them with zero danger to their health. After spending 50 to 100 years in storage, it's time to send these casks underground to a deep geological repository to live out the rest of their days. To transport the casks, robotics are used to place them in containers made of 31 metric tons of stainless steel, which are loaded onto trucks and sent on their way. These stainless steel containers have been put through the most rigorous safety testing imaginable, including being hit by locomotives, dropped from very high up, submerged in water, placed at explosion blast zones, and they have proven to be impervious in all those scenarios and more. Of course, these containers aren't just thrown into random holes. They are placed 650 meters below the surface in a part of the Earth's crust where no meaningful amount of water can be found. This is important because the only risk of the nuclear waste someday popping back up on the surface is if enough water is present to eventually dissolve the spent fuel. However, this deep in the ground, the chance of that happening is very small. Here's Per Jander, director of WMC and an expert on nuclear power, to explain further.
Prior to going into the core, nuclear fuel is completely harmless. You can touch it, you can stand right next to it, nothing really happens to it. After the core, very different story, absolutely. Then you keep it in water for a year or two before you transport it anywhere to let the worst heats kind of cool down. And then there's different approaches in different countries. Most countries have what's called a dry cask storage, where you put them on a concrete pad, outside, but they're in well shielded concrete casks. And I'm sure you've seen tons of pictures. It's very easy to find pictures of people standing right next to these, and they're warm, nice lukewarm, but the radiation on the surface is no different than it is anywhere else. So obviously they're very, very effective at shielding. Other countries, such as Sweden, for example, you have this intermediate storage of just putting them underwater. So they have one central storage facility for the entire country where all these spent or used fuel bundles are put, and they let them sit there for 40, 50 years, and then we're going to start putting them into the final repository. So different approaches in different countries, but the basic thing is you put them in intermediate storage for the worst radioactivity to calm down, and then you can move into a final depository, which in most cases are going to be deep underground.
But wait. If we have to store all the nuclear waste in these huge casks in holes underground, surely we're going to run out of space eventually. That brings us to our next point. Part 2. The amount of nuclear waste that results from energy generation is very small, especially when compared to other energy sources. This statistic has been repeated ad nauseum, but it's worth mentioning it again. So here's a quote from the Nuclear Energy Institute. All of the used fuel ever produced by the commercial nuclear industry since the late 1950s would cover a whole football field to a height of approximately 10 yards. And that's not just for the United States, it is used fuel for the entire planet. Let's compare that to other baseload energy generation options. Fossil fuels, such as coal, produce an incredible amount of toxic waste that is released into the air. Burning coal produces sulfur dioxide, nitrogen oxides, particulates, and more, which contributes to acid rain, respiratory illnesses, smog, lung disease, and other issues. Of course, that's coal, the dirtiest form of energy production still used at present, so maybe it's not a fair comparison. What about natural gas? Well, it is the cleanest burning form of fossil fuel-based power generation. It still produces far more harmful waste than nuclear power. The important factor here is that every single gram of nuclear waste is accounted for and must be safely stored away to meet stringent regulations. With fossil fuels, the impact is much more difficult to physically see, measure, and contain. When we examine these facts, there's no doubt that the impact of nuclear waste on the planet is much smaller when compared to the alternatives. And before you bring up wind and solar power, well, these are promising technologies. They are intermittent, not baseload sources of power, and have never been used exclusively to power a grid. Here, once again, is Per Jander to break things down for us.
Of course, life cycle waste of a nuclear power station, concrete mostly, steel, and the absolute majority of that is not even radioactive. That's why sometimes you leave it for a decade or two because then you can declassify a lot of this material. It might be marginally radioactive for 10 years, but after that, it's just regular concrete. So then you don't even have to worry about it. So that's obviously lifetime stuff. Now, I think what most people focus on when it comes to nuclear waste or spent nuclear fuel is the fuel itself. And that's obviously where we need to come to, like the operating waste stream that if you get. And I think a good comparison, it's about the volume of a brick per person for a year. But out of that brick, 90% or more is low radioactive waste. It's just clothing, or it's just chemicals, or just material that it's very little radioactivity on, that you don't really have to worry about. Sure, you put it somewhere, but a landfill, and then 5 years later is not really anything to worry about anymore. But when it comes to the high level waste, it's 5 grams per person per year. It's virtually nothing. The interesting thing now is when the headlight is a bit turning to the other sources of energy. Well, what are you guys doing in your waste then? And I think the further this debate is going, the more it's going to become clear that nuclear energy is a very, very responsible when it comes to taking care of its own waste stream.
Okay, so we have a solution for dealing with nuclear waste, and the quantity and impact of this waste is small. However, what about accidents when dealing with the waste? Surely there's been a few. Well, Part 3. There has never been a single accident involving nuclear waste. Although there have been a few accidents involving nuclear plants, with the only one including fatalities being Chernobyl, none of these incidents involved spent nuclear fuel or radioactive waste. Even in the Fukushima meltdown of 2011, the spent fuel rods and cooling ponds on site did not leak radiation or contaminate the environment. Over the course of 70 years, operating 500 nuclear reactors in over 30 countries, there is not a single recorded incident of anyone dying from exposure to nuclear waste or spent nuclear fuel. There is a whole other subject of just how serious most of the recorded nuclear accidents were, and the truth is, far less serious than the media would have you believe. And when it comes to nuclear waste, you can rest assured of its strong safety record.
Technologically, it's not difficult. Just cover it up. That's all you need to do. And again, it's how the distance to it, it's how time, but it's the measurement techniques we have are so sensitive that you will know right away, and we've gotten really good at it. So it's you know how radioactive it is, you know what it takes to shield it, and the means of shielding it are not that complicated. So it's been a very, very good track record.
Part 4. The radiation present in spent nuclear fuel declines to levels that are harmless to all forms of life. This is the one that most people have trouble wrapping their heads around. After all, we've all heard about how some of the radioactive isotopes present in nuclear waste have a half-life of thousands of years. So surely there's a danger that the stored nuclear waste could someday be exposed to the environment again and wreak havoc. Well, not really. When spent nuclear fuel is first removed from a reactor, it is very radioactive, and if the safety precautions we outlined earlier weren't in place, the spent fuel could cause great harm to anyone in the nearby vicinity. However, these high levels of radioactivity decline to harmless levels faster than you might think, as long as the spent fuel remains in a protective cladding. Let's break down the different kinds of radioactive waste present in spent fuel. The first are radioactive isotopes lighter than uranium, namely cesium-137 and strontium-90. These two isotopes are responsible for the vast majority of penetrating radiation in the spent fuel, so it's a good thing their half-life, which refers to the time it takes for the radioactivity of a specified isotope to fall to half its original value, is only around 30 years. After 60 years, it still has 25% of its radiation, and eventually, radiation levels will fall further until it is no longer a danger to anyone. The second kind of radioactive waste are isotopes heavier than uranium, such as plutonium-239, which has a different type of radiation than the lighter isotopes, but a half-life of 24,000 years. That might sound scary, but the truth is, plutonium-239 isn't very harmful to begin with, as it mostly emits alpha particles, which are easily stopped by fuel cladding, skin, or any other simple barrier.
The shorter half-life, the more intense the radiation, right? So that's why when it's like, oh, it's got a half-life of 24,000 years, yes, that also means that there's almost no radioactivity coming out from it. So something that has a half-life of 10 seconds, yeah, that's going to be like a little very, very bright light. Eventually, it's just radiating everything, but it also means that the radioactivity is gone fairly quickly. So if you look at a spent fuel rod that's coming out of a reactor, after 40 years, you have 0.1% of the reactivity left. That's only after 40 years. So the reactivity has gone down by 1,000, a factor of 1,000. So, and the vast majority of the radiation, like 95% of it, is from these smaller fission products that you talked about, something that's created when the atom splits. Like these atoms aren't very comfortable where they are. They have way too many neutrons, if you want to get technical. So they tend to move again. And you basically have these chains before they come into an isotope and an atom that is more stable. So during this period, which depends on what material it is, but again, that 400-year period, after that, you're more or less certain. Like now, there's only alpha radiation left that we have to worry about. The other types of radiation are gone, not as intense anymore. So the shielding works just fine in protecting it. So the really bright, heavily radioactive stuff, that's gone. Now it's more of a matter, make sure that it's shielded from humanity so it doesn't enter our bodies either through inhalation or ingesting. And it's as simple as that.
One further point to keep in mind. We are actually all exposed to radiation in our daily lives. This background radiation comes from natural sources such as radon, a gas that forms when uranium, thorium, or radium breaks down in rocks, soil, or groundwater, as well as from cosmic rays, the Earth itself, and even our own bodies. We are also exposed to radiation when taking a flight, and of course, through medical procedures such as getting an X-ray. All of this radiation exposure is perfectly harmless and we don't even notice it, but it is actually thousands of times higher than any radiation you could be exposed to from safely stored used nuclear fuel. And there you have it. Nuclear waste is not something to be feared. The care with which it is handled and stored contributes to the fact that nuclear power is one of the safest forms of baseload energy generation known to humanity.